Hi guys, so in this lecture we'll be talking about some of the concepts of acid and base because we'll be requiring it in the subsequent lecture. So just some theories on acid and base if you don't have the required skills in it. So yeah, there is a popular Arrhenius theory here which tells that acid is acid gives H plus and base gives OH minus. Now next comes the Lorry-Bronsted theory, where we have that just remember APD and BPA. Full form is acid is proton donor, base is proton acceptor. Acid is proton donor, base is proton acceptor. Okay, now let's look into some examples. We have H2O plus HCl gives hydronium ion plus Cl minus. Okay, so in this case oxygen gives the charge to attract H atom, so this is base, and as this compound donates H plus, it is acid. So base accepts proton and acid donates proton. Okay, so in the formed compound, this would be named as conjugate acid, and this would be named as conjugate base. Why? Because if in some case reverse reaction also happens, then in the reverse reaction this would be proton donor and this would be proton acceptor, which on accepting proton it will become this, and this on donating proton will become this, or base, right? Let's look into another example. We have H2O plus HNO3 gives H3O plus NO3 minus. So in this case H2O is base as it accepts proton, as it accepts proton. This is acid as it donates proton. This would be conjugate base because in the reverse reaction it will be donating, the conjugate acid, as in the reverse reaction it would be donating H plus, and in the reverse reaction this would be conjugate acid as it will be conjugate base as it would be accepting proton to become HNO3 in the reverse reaction. Okay, so let's take one more example. We have NH3 plus HBr gives, now this N atom actually accepts proton and becomes positively charged and releases Br. So this would be base here, this would be acid here, this would be conjugate acid here, this would be conjugate base here. Okay, so for the next set of questions I am writing some examples, or I am writing some acids you need to draw conjugate base out of them. Draw conjugate base. This is your question, this is your task. So we have for H2O conjugate base would be H3O plus. Okay, will it be the conjugate base? No. Why? Because if I am writing that this is conjugate base, this should be acid, right? So this should not be the answer should be, when it is an acid it should donate proton to become OH minus. This would be the conjugate base, right? In the second example, if we have OH minus, you need to draw conjugate base. This means this has to be acid, so it should donate one more electron, one more hydrogen atom. In this case, if it has to be conjugate base, this has to be acid. This means it will convert itself into NH2 minus. Similarly, in fourth example, if we have ROH, it has to be conjugate base, so this has to be acid, so it has to be donating H plus. Okay, so the next example, you need to draw just the opposite. Draw conjugate acids. So if I am telling you have to draw conjugate acids of the following, what should come in your mind? That this should be considered as a base, so it would be accepting OH plus H plus to form itself conjugate acid. Second example is you need to draw conjugate acid for this thing. For conjugate acid, it should be a base, it should accept one H plus ion, so to conform itself to be a conjugate acid. Third example is NH3. For it has to be conjugate acid, this has to be base, accept a proton, become NH4 plus. Fourth example is NH2 minus, it has to be base, accept proton, become NH3. Okay, so what is Lewis theory? This was according to Lorry-Bronsted theory. What is Lewis theory then? Lewis theory. Lewis theory states that acid accepts pair of electron, base donates pair of electron. Simple as that. Acid, let me write it more clearly. Acid accepts pair of electron and base donates pair of electron. Okay, so let us look at this example. We have something like this. So this is donating its lone pair into okay, so it would be donating its pair of electron into the free d orbital of aluminium. Similarly here, so what will happen is this will become a positively charged, this would become a negatively charged. So this is a Lewis base, this would be Lewis acid. Okay, let's take another example. We have pyridine. I hope you remember pyridine. And we have BF3. And what is so important about BF3? That it has one empty p orbital, right? So as it has one empty p orbital, nitrogen will donate its lone pair to that, resulting in formation of compound something like this. Okay, so in this case this would be Lewis base and this would be Lewis acid. Okay, so some things to remember, or let me write it as important things. So we have something like, if acid is actually donating its proton and becoming negatively charged anion, then Ka value is defined as concentration of H plus A minus upon concentration of Ha. So higher the Ka value, higher is the acidic strength. So we can write that Ka is directly proportional to acidic strength. Okay, and pKa value is actually minus log of Ka value. Hence, this implies pKa value is inversely proportional to acidic strength. How? I'll just give you an example. For example, if I have A which is more acidic than B, the concentration or the Ka value is 10 to the power minus 3 and here 10 to the power minus 4, then pK value for A, pK value for in case of A comes out to be 3 and pK value of B actually comes out to be 4, but this was more acidic. Hence, pK value is inversely proportional to the acidic strength. So this brings us to the end of this lecture. In the next lecture, we'll be seeing effect of acidic strength on plus M plus H plus I and other things. Okay. Till then, good luck and goodbye.